Utilization of Crumb Rubber in flexible pavements. Abstract: India's waste tires account for about 6 to 7% of the global total. With the local tire industry growing at 12% per annum, waste volumes are rising. India has been recycling and reusing waste tires for 4 decades, although it is estimated that 60% are disposed of through illegal dumping. Modern tires are fundamentally rubber products. They are a complex mix of natural and synthetic rubbers, and various structural reinforcing elements including metals and chemical additives. This complexity has led to stockpiling, dumping, and diversion to landfill. This has exposed communities to environmental and health risks and has squandered valuable resources locked up in tire dumps. Stockpiled tires are at risk of fire and toxic smoke. Other risks include the stagnant water in tires that provides breeding grounds for mosquitoes and leaching of toxic substances into soils. India is the second largest producer of reclaimed rubber after China. In 2011, India produced 90,000 metric tons of reclaimed rubber from waste tires. We have developed Crumb Rubber Modified Bitumen, which introduces a simple modification into the conventional manufacturing process for bitumen. Keyword: stockpiling, stagnant water, synthetic rubber, waste tire, CRMB. Introduction: Bituminous pavement has a poor susceptibility due to water, heat and axle load. Its solution is modified bitumen, which is made by Crumb Rubber plus bitumen. Crumb Rubber is the scrap tire shredded into small pieces by the help of mechanical blades up to sizes of 1 mm. 75 mm CRMB was developed by Charles McDonald, an engineer with City of Phoenix, Arizona, U.S. Development in 1960s. Crumb rubber is obtained from truck or automobile tires. Whole truck tire contains 18% of natural rubber compared to 9% in automobile tire. It is produced from discarded rubber by 2 methods, i.e. ambient grinding and cryogenic grinding. There are 2 methods to mix tire in bitumen. One is dry process and second is wet process. Dry process is introduced by 2 Swedish companies. In this process, crumb rubber is used as a substitute for a part of mineral aggregate. However, in wet process the crumb rubber is thoroughly mixing with bitumen and allowing it to react for a period of 45 to 1 hour. High temperature should be maintained. A history of using crumb rubber as a modifier in bituminous pavement. Incorporation of crumb rubber with conventional bitumen has been practiced for more than a century. The first attempt was taken in early 1840s, which involved mixing of natural rubber with bitumen to improve the desired engineering properties. Modification process of bitumen by natural and synthetic rubber was introduced at early 1843, Thompson, 1979. The modification process both by natural and synthetic got further improvement in 1923, Isaacson and Liu 1999, Yildirim, 2007. Yildirim stated that the development of rubber bitumen materials being used as joint sealers and patches began in the late 1930s. According to the study of Hansen, in 1950 the use of scrap tire in asphalt pavement was reported, Hansen, Fu, Brown and Denson 1994. In 1960, Charlie MacDonald reported successful use of scrap tire rubber as an additive in bitumen binder modification. He concluded that after mixing of crumb rubber with the neat bitumen and allowing it to blend for mixed duration of 45 to 60 minutes, there were new material properties produced, which resulted in swelling in the size of the rubber particles at higher temperatures, allowing for higher concentrations of liquid bitumen contents in pavement mixes. Huffman, 1980. In the mid-1980s, the Europeans began the development of different polymers and additives for application in bitumen binder modification. Brule, 1996. In recent years, the use of crumb rubber has gained interest in pavement modification and has shown that crumb tire rubber can improve the bitumen performance properties. Brown, Jared, Jones and Watson 1997. It is reported that during the bitumen rubber thermal blending, due to higher stiffness and tensile strength at elevated temperatures, the modified bitumen had decreased rutting capability. Pallet, Sudhakar and Pandey, 2004. B. Material collected. Crumb rubber collected from a local tire retreading shop near Lonera, Batu University was used to modify 80/100 penetration graded asphalt obtained from Public Works Department laboratory located in Mangjayan. The crumb rubber was generated by scrapping old tires of automobiles with use of buffing machine. Crumb rubber passing from 30 mm sieve and retain on 50 mm sieve was used. Ductility test, penetration test were conducted on plain bitumen. 2. Literature review. A. International Journal of Engineering Research and Technology, IJRT. V. Suganpriya, S. Omparkash, V. Chandralaga presented their research in this paper titled Study of Behavior of Bitumen Modified with Crumb Rubber. The aim of the study was to utilize the waste materials, i.e. crumb rubber waste, for mass-scale utilization such as in highway construction in an environmental safe manner. As a first part bitumen compared to pure bitumen concrete mix at both low of the study, an attempt was made to assess the stabilization and high temperatures of the bitumen containing crumb rubber waste in shredded. 3. Methodology formed by performing basic tests such as penetration test, ductility test, softening point test, viscosity test and A. Tests conducted. Flash and fire point tests. On the basis of the performance of 1. Penetration test, it measures the hardness or the modified bitumen, the range of optimum percentages of softness of bitumen by measuring the depth in crumb rubber tenths of millimeter to B. International Journal of the Physical Sciences volume which a standard loaded needle will penetrate vertically in 5/7, 2, pages 166-170, January 9, 2012 seconds. Bhise had standardized the equipment and test. Nuha S. Mashan, Asim Hassan Ali, Mohammad Rian procedure. The penetrometer consists of needle assembly. Karim and Marez Abdel Aziz presented their research in with total weight of 100 g and a device for releasing, and this paper titled An Overview of Crumb Rubber Modified Locking in Any Position. The bitumen is softened to a pouring asphalt. This review study presented the application of consistency, stirred thoroughly and poured into containers at Crumb Rubber Modifier in the asphalt modification of flexible a depth at least 15 mm in excess of the expected penetration. Pavement. From the results of previous studies, it aspires to the test should be conducted at a specified temperature of. Consider crumb rubber modifier in hot mix asphalt to 250 C. Improve resistance to rutting and produce pavements with equipment used. Mold 1, 8.3 cm dia, Mold 2, 6 cm dia. Better durability by minimizing the distresses caused in hot penetrometer, digital, needle, digital timer, lubrication. Mix asphalt pavement. Hence, road users would be ensured oil, benzene, cleaning purpose of safer and smoother roads. Waste was selected for further. 2. Ductility test. Ductility is the property of bitumen investigations that permits it to undergo great deformation or elongation. Ductility is defined as the distance in cm, to which a standard. See International Journal of Recent Technology and sample or briquette of the material will be elongated without. Engineering, IJRT, ISSN, 2277-3878, Volume 8. Braking. Issue 1, May 2019. Equipment used, Mold number 2, 4, 8, Petroleum Jelly, Locking. Hanumantharao, Anil Pratyumana, Durgaprasad, Nuts, Ductility Machine, /lubricant oil, water, 80/100. Navin Kumar, Shantha Kumar Reddy, Hemant Vardhan, Penetration Grade Asphalt, Metal Pin, Diesel and Cotton. Presented their research in this paper titled Crumb Rubber Refrigerator, Blade, and Knife. Modified Bitumen and Quarry Dust in Flexible Pavements. The comparison of pure bitumen and modified bitumen B preparation to make crumb rubber modified bitumen using waste crumb rubber is studied experimentally, and blend discussed about the resistance against fatigue cracks, rutting. In preparing the modified binders, about 500 gm of the cracks, Strength of bitumen road and durability of modified. Bitumen was heated to a fluid condition in a 1.5 liter capacity bitumen at both high temperatures and low temperatures. Metal container. For the blending of crumb rubber with. Using Marshall stability analysis. The quarry dust, which. Bitumen, it was heated to a temperature of 160 degrees Celsius and then is another waste generating from the quarries, is used as fine. Crumb rubber was added. For each mixture sample 0%, 8%, aggregate and filler. 15% of 20 mm, 25% of 12.5 mm, and 10%, 12%, and 14% of crumb rubber by weight is used. The 15% of 6 mm as coarse aggregate and 45% of quarry dust as blend is mixed manually for about 3 to 4 minutes. The mixture fine aggregate and filler material is used. Waste crumb is then heated to 160 degrees Celsius and the whole mass was stirred. Rubber materials are added to pure bitumen using wet process. Using a mechanical stirrer for about 50 minutes. Care is taken with percentage of 5%, 10%, 15%, and 20% crumb rubber. To maintain the temperature between 160 degrees Celsius to 170 degrees Celsius. The width size of 0.300 mm to 0.150 mm. Laboratory results. Contents are gradually stirred for about 55 minutes. The indicated the crumb rubber can incur high elastic behavior. Modified bitumen is cooled to room temperature and low penetration and high softening point compared to pure. Suitably stored for testing. Bitumen. Also high stability and flow values of modified. See readings. For conclusion. The objective of the study was to utilize the waste materials, i.e. crumb rubber waste, for mass-scale utilization such as in highway construction in an environmentally safe manner. The bitumen of grade 80/100 was taken and it was modified with different percentage of crumb rubber starting from 4% to 12%. From the results, the maximum percentage of crumb rubber as bitumen modifier was in the range 10–12% by the weight of binder content. It was observed that values of penetration and ductility are reduced by 14.56% and 24.49% respectively, by the addition of 12% crumb rubber waste. Overall, using the crumb rubber in bituminous mixture helps to utilization of crumb rubber waste. Reduction in the use of bitumen by around 10%. Increase in the strength and performance of the road. Provide better adhesion between the asphalt and the aggregate. Avoid the use of anti-stripping agents. Reduce the cost. Avoid disposal of crumb rubber waste by incineration and landfilling. Acknowledgement. I express my heartily gratitude towards our head of department for his personal involvement and constructive criticism provided beyond technical guidance during the course of the preparation of the report. He has been keen enough for providing us with the valuable suggestions from time to time. Above all, his keen interest in the seminar helped us to come out with the best. Thanks to Drive SM Pore, of Civil Engineering Department, Dr. Babasaheb Ambedkar Technological University, Lonera, for encouragement and providing necessary information. I was ending this acknowledgement with deep indebtedness to Professor S.V. Bhise, all the other faculty members, and our friends who have helped us directly or indirectly for completing this manuscript.